which we use to model the geometric figures. In other words, we are using algebra to analyze geometry. The resources that you are going to need before you settle down: get a paper, a graph paper preferably, but if you don't have a graph paper, just get a normal paper, a pencil, a ruler, and a calculator. And then on your paper, draw a set of axes. The pre-knowledge that we need in this topic: you need a good background of algebra. You also need a good background of grade 9 geometry. The key concepts in this topic: we have gradient. And when you talk of a gradient, think of the parallel lines. Think of perpendicular lines. Think of the points on a straight line or the collinear points. Another key concept: we have distance, we have midpoint, we have equation of a line, we have angle of inclination, and then we have an unknown point. Sometimes analytical geometry is referred to as the coordinate geometry. The reason being that everything that we'll be doing, we will be on a coordinate system, meaning that we'll be referring to points, or every figure that we'll be doing, it will be coming down to points. And you know, a point, it's given as an ordered pair of an x value with the corresponding y value. All right, now I hope you're having all the resources that I requested you bring. So on your paper, you're having your Cartesian plane or your set of axes. So we are going to locate our points so that when we illustrate all those key concepts, we can follow on what we are doing. So on your Cartesian plane, locate a point. My first point, I call it P, and it is a point on the first quadrant with coordinates 1, 1. So the x value at P is 1, and the corresponding y value is 1. Locate your second point. I call it Q. And your Q has coordinates 0, -2. Meaning that your x value at Q is 0, and the corresponding y value is -2. And then I have my third point. I call it R. And my R, it's a point on the right hand side of P, and it is below Q. And then it is in the fourth quadrant. It's a point on the fourth quadrant, and it is below point Q on the right hand side of angle P. So from the points, we make lines. So if you join your point P and point Q, you're going to have line PQ, and then you join your point P and point R, you're going to have line PR, and then you join Q and R. And then you're going to have line QR. From the lines, now we have a geometric figure, which in our case we are having a triangle. So we have moved from a point to lines, and from the lines we have our geometric figure. And then that's why we start analyzing our geometric figure using algebraic mechanisms. And then we go back to our key concept. I said that the first key concept that we'll be looking at is the gradient of a line. So you take your formula sheet and check our formulas. We have the formula for the gradient, which is given by change in y over change in x. So we are going to find the gradient of line PQ. Before we find the gradient of PQ, you're having point P, you're having point Q, but then we're not having the coordinates of point R. So the line PQ is given by equation y is equals to negative x plus 2. That is the equation of your line PR. And then QR is defined by equation x plus 3y plus 6 is equals to 0. And then I am having angle R. My angle R, which is formed by the intersection of line QR and line PR, I am going to refer to that as theta. It is angle R, but let us refer to it as angle theta. Now we are going to calculate the gradient of line PQ. And then by the definition of a gradient, it is given by the formula change in y over change in x, which is telling us about how is y changing, the rate of change in y with respect to x. So if I am talking about the gradient of line PQ, it means I am going to look at the change of y between P and Q. So I am going to have y at P minus y at Q divided by x at P minus x at Q. So you'd note from the definition of the gradient or the formula, there is consistency with the point which I start with. If you look at the denominator, I started with y at P. Hence, when I go to the denominator, I am also starting with x at P. If I started at Q, it means even from the denominator, I would have started at Q, because that consistency is very important. And then we make our substitutions. We go to our points, and then we look for the y value at P. And then our y value at P, it was 1. And then y value at Q is negative 2. So I am having 1 minus negative 2 when I make substitutions there. And then it's divided by x at P. X at P is 1 minus x at Q. And my x at Q is 0. And then you compute there. You have 1 minus negative 2. It is positive 3. And then 1 minus 0. It is 1. So our gradient of PQ is 3. Okay. So we are having the gradient of the line PQ is positive 3. And then if you recall from the graphs and functions, when you learned about the straight line, you note that even before we calculate the gradient of PQ it's an increasing function. And then because it's an increasing function, you expected the gradient of PQ to be a positive number. So if you make calculations, because when you calculate, sometimes you make mistakes. So you always have to check your expectations with the actual results that you have. Do they make sense to you? Because if you have an increasing function and the gradient is negative, then there is contradiction there. Then something is not right. You have to go back and check where you missed the calculations or steps. Okay? And then still on gradients, when we talk of gradients, remember, if I have two lines which are not touching each other, or that I can't see if they are going to touch each other somewhere, we can calculate or we can check if the two lines are parallel. But then from the sketch that you are having, you see that PR, QR, and PQ, all of those lines are having an intersection. So we can't even think or try to check if any of the lines here are parallel, because all those lines have an intersection at some point. But then when the lines have intersection, we can check if the lines are perpendicular. And then by the definition of perpendicular, when you say the lines are perpendicular, what you're saying is that where the two lines meet, they form an angle of 90 degrees. And then in analytical geometry, we are saying that the product of their gradients is equal to -1. So if my two lines are perpendicular, I can check and confirm that my lines are perpendicular by multiplying their gradients and confirm that the outcome is -1. And if I don't get -1, what it is telling me is that my lines are not perpendicular. And then normally I tell my learners to do that all the time, even though the question doesn't say proof or show that the two lines are perpendicular. And my reason for doing that is because learners, when a question comes saying prove the lines are perpendicular, already they give that statement as if it's already proven. While what they're supposed to do is to move from the left-hand side of that equation. From left-hand side, and then they must arrive at the right-hand side. So, to check that my lines are perpendicular, I can check, I am having 3 lines here, so I can check line PQ and PR and check if the two lines are perpendicular. So it means we're going to multiply the gradient of line PQ and the gradient of line PR. And then we have calculated the gradient of PQ here. We said is +3. And then we are going to talk about the gradient of PR. PR is given in a form of an equation. And we know that our equation of a straight line, if it is in standard form, the coefficient of x, it is the gradient. So if your line or equation of your line is not in standard form, you have to write your equation in standard form first before you can talk about the gradient of that line. So my line PR is given in the form of equation, and that equation is y is equals to -x plus 2. So our -x plus 2, it is in standard form because it is in the form of y is equals to a constant multiply x plus 2. So we can actually talk about the gradient of that line, which is the coefficient of x. And coefficient of x is -1. So that is saying that the gradient of PR is equals to -1. am having the gradient of PQ, I am having the gradient of PR. So to check if the two lines are perpendicular, I am going to multiply the two gradients. So I am going to take the gradient of PQ, multiply the gradient of PR. And when I do my substitutions, I said the gradient of PQ is positive 3. So I have positive 3 multiply the gradient of PR, which is negative 1. So when I multiply 3 by negative 1, my product is negative 3. Now, we go back to our question. We were checking if the two lines are perpendicular. And then I look at my product and say the product of the two gradients is giving me negative 3, which tells me that the two lines are not perpendicular because the outcome that I have is not negative 1. Okay, so I can check another lines. If you have time, you can do all of the intersections, meaning you can check if PQ is perpendicular to QR. You can check if QR is perpendicular to PR. But then for the sake of time, we're going to do the last one. We're going to check PQ and QR. So I am going to talk about the gradient of PQ. And then remember, we have calculated the gradient of PQ and then we said is positive 3. And then now we are going to talk about the gradient of QR. And QR has been given in a form of equation. X plus 3y plus 6 is equals to 0. And then when we look at that, equation is not in standard form. So before we start talking about the gradient of that line, we must write it in standard form. And then writing it in standard form, basically what we do is to make y the subject of the formula and then have the coefficient of x, which will be our gradient. So we are going to write our equation in standard form. We are having plus x, we are having plus 6. So we are going to remove those two with their additive inverses. And then we're having 3, which is multiplying y. It means we're going to remove it by its multiplicative inverse. So when we do all those, we're going to have y is equals to negative x minus 6 divided by 3. And then you separate your terms because for you to talk of the gradient, it means you have to clearly see what is the coefficient of x. So I am going to have negative 1 over 3 x. And then here I have negative 2. So equation of line QR, if I write it in standard form, it is going to be negative 1 over 3x minus 2. Now I can talk about the gradient of that line. And then the gradient of the line, it is the coefficient of our x. So coefficient of x is negative 1 over 3. So that is saying that the gradient of QR is equals to negative 1 over 3. And then we want to check if the two lines are perpendicular. I'm going to multiply the two gradients. The gradient of PQ, I'm going to multiply it by the gradient of QR. And then when I make the substitutions, the gradient of PQ is 3. I multiply it by the gradient of QR, which is negative 1 over 3. When you multiply 3 by negative 1 over 3, the product is negative 1. And then we go back to our question. Are the two lines perpendicular? And then we answer by saying, yes, they are perpendicular because the product of my gradients is equals to -1. So we don't start by saying that the product of the gradient equals to -1. That is what we must show. That when I multiply the gradient of the two lines, I end up with the result which is -1. So it means I can go to my sketch now and show that angle Q is 90 degrees. Because when we say that the lines are perpendicular, we are saying where they intersect, they form an angle of 90 degrees. So we have a right-angled triangle because one of the interior angles of that triangle, it is 90 degrees. And then we have shown that by showing the multiplication of their gradients, that it is equals to -1. Okay, so I hope as your home activity you're going to do the remaining two lines. I did 2, and then you're going to do the third one, meaning you're going to check if angle theta is 90 degrees or not. Still on gradients, we have what we call collinear points, or the points on a straight line. When we studied the graphs and functions, you were told that the gradient of a straight line is constant, meaning that it does not change. So if you can calculate the rate of how y is changing against x of a particular line, then it doesn't matter where you are in the line, the gradient will be the same. So if I have any points on line PQ, for example, if I take any 2 points, calculate my gradient, it is going to be +3. Because on that line, I have seen using point P and Q that the gradient is 2. So what we are saying here is that the gradients of points which are collinear, or points which are on the straight line, their gradients are equal. So this information, sometimes you may ask why I am mentioning it. The reason why I say it is because sometimes they give you that knowledge that the points are collinear. In basic way of analytic, they will be telling you that the gradients of any 2 points in that line is equals to +3 if we are in PQ. Okay, so that is about the gradient of a line. And then you see if you are given an equation, it means you can identify your gradient by taking the coefficient of x after writing your equation in standard form. But then if you're having 2 points, you can calculate your gradient by checking the rate of change between any points in that line. Okay, now the second key concept here, we are going to look at the distance. When you talk of the distance, if I am having 2 points, I'm actually talking about the distance between those 2 points. Or I can say that is the length of the line. Because when I say the length of the line, it means it is the distance from the first point to the other point. So how do we calculate the length of a line or the distance between 2 points? If I am looking at my 2 points P and Q, I can find my PQ, meaning the length of PQ, which is given by the formula, the square root of x at P minus x at Q squared plus y at P minus y at Q squared. This formula is coming from theorem of Pythagoras, because we can actually construct a right angle triangle. If I move vertically, I will be talking about the change in y. And then when I move horizontally, I'm talking about change in x. So I go and make my substitutions on my formula. I am going to substitute the x at p. We said that x at p is 1. So I have 1 minus x at q. At q, x is 0. So I subtract 0. And then squared plus y at p. At p, my y is 1. I substitute 1 minus y at q. So I am going to minus negative 2. And then I square. Then you make your calculation there. 1 minus 0 is 1, and then you square. That will be 1. And then plus. So I am going to have my line PQ being 10. The square root of PQ is 10 units. Okay, that is the second key concept in analytical geometry. The third, midway between the 2 points. So when we calculate the midpoint, remember when we talk of a point, all the time we are talking of the x value with the corresponding y value. So when we talk of a midpoint, it means we would want to know the x value at midpoint and then the corresponding y value. So the x value, we're going to get it by taking the average between the 2 points. If I talk of the midpoint of PQ, it means the x coordinate at midpoint is going to be x at P plus x at Q divided by 2, and then the corresponding y value will be y at P plus y at Q divided by 2. And then when you make your substitutions, you're having x at P is 1 plus x at Q is 0 divided by 2. And then the y coordinate, y at P is 1 plus y value at Q, which is negative 2 divided by 2. Then 1 plus 0 is 1 divided by 2, meaning the x coordinate at midpoint of PQ is half. And the corresponding y coordinate, I have 1 minus 2, which is going to be negative 1 divided by 2, which is negative half. So the midpoint of PQ is given by coordinates half and negative half. So sometimes you find that they give you the midpoint of a line and then you are requested to find the point at the other end. So you still use the same logic. You make equations from there because you know that this will be equals to the x value at midpoint. And then if one of this is an unknown variable, one of the x coordinates at the end, then you're going to make equation and then you make whatever x is missing. Okay, and then the next key concept that we're having, we are having equation of a line. And then when you look, line QR was given in the form of equation, line PR was given in the form of equation. So we can actually calculate the equation of line PQ. And then we know that equation of a line is given by the standard form of y is equals to mx plus c. So when you look there, we are having 2 variables, x and y, and we are having 2 constants. M and c are constants. So when we define equation of a specific line, what we are saying is that tell us what is M, tell us what is C. Because X and Y, they change depending where you are in the line. For example, look at that line PQ. At P, my X was 1 and Y was 1. But when I move to Q, my X is 0 and my Y is -2. But the constants, they will still be the same. At Q, the constants M and C, they will be the same as the constants at P, because those points are collinear. They are on the same straight line. So M, it is the gradient of a line, and then we have calculated the gradient of this line. We said that M is +3. So I go to my general form and substitute M by 3. So I have 3x plus C. And then C, when we learned the graphs in grade 9, grade 10, you were told that C, it is what we refer to as the y-intercept, meaning it is where the graph or the line will be cutting your y-axis. So this is my y-axis. The vertical axis, it is my y-axis, and then it is cutting at point Q. And then I go and check on that point and say, my y at Q is -2. So I am going to substitute my C by -2 because that's where the graph cuts the y-axis. So the equation of that line will be 3x minus 2. Sometimes you are not given the y-intercept. So meaning that after finding the gradient, you must go on and calculate the value of C. So when you calculate the value of C, you just pick any point on that line, that pair, and then you substitute the x value with the corresponding y value at that particular point, and then it will tell you what C is. Because like I said, the C and M, it doesn't matter where you are on the line. Those values are constant. And then that is meaning now we are having line PQ can be defined as y is equal to 3x minus 2. So all of our lines now are defined in form of equations. All right, now we are going to the main concept, which is new one in grade 11. The rest of what we have been doing, it is actually grade 10 work, even though because we are carrying it forward up until grade 12, we have studied this, or the assumption is that we have done all of this in grade 10. So the new concept, which is new in grade 11, we are talking about angle of inclination. When we talk of angle of inclination, we are talking about the angle that your line of reference makes with the positive x-axis. Let us look at the two lines which are intersecting the x-axis at the moment. Well, not two of them, but then all of these lines at some point they intersect the x-axis. But let's talk about the ones which are intersecting from our sketch. If you look at line PQ, our line PQ is making an angle of inclination. When you look, when it crosses the x-axis, it divides that line into two regions, the left-hand side of the line and the right-hand side of that line. So when we talk of angle of inclination, we are on the right-hand side of our x-axis, and then we move anti-clockwise to touch the line. And then we form an angle there, which you call angle of inclination. And then when we form that angle, it is related to the gradient of the line. Because when you remember from trigonometry, we have spoken about the trig ratio tangent, which is given by the ratio of y over x. And if you can remember, when we talked of the gradient of a line, we said that it is change in y over change in x. So, angle of inclination, it is the angle which relates to the gradient, because the tan of that angle is equals to the gradient of a line. Okay. But then when you move from the positive x-axis, like I said, that when the line intersects the x-axis, it cuts your axis into two sides. So when we move from the positive x-axis to the line, we can move from the x-axis to the line in an anti-clockwise direction. And then when we move in an anti-clockwise direction, you are going to see a positive angle. And then if you move from the x-axis, or the 0 degrees, because that is what we refer to as 0 degrees, you move clockwise, you are going to have a negative angle. And the reason why x-axis moving anti-clockwise, or I can touch my line moving clockwise, meaning I move with a negative angle. So that negative and positive angles, they're actually just telling us about the direction from the x-axis, which direction are we traveling. But then what you notice that the two lines, they are going to that line of reference. In our case, we are talking about line PQ. So those angles, they form 180 degrees, or they are supplementary angles. Because if I move from the x-axis to the line PQ, and I move from the x-axis to line PQ in the negative direction, or in the clockwise direction, I am making a straight line. And angles of a straight line gives us 180 degrees. And my point being that when you calculate the tan of an angle, it's going to give you the gradient of that line. But if you are looking for an angle, you can actually get either the angle of inclination, or you can get the supplementary angle to the angle of inclination. And then you are going to differentiate between the two by looking at the sign that you get when you calculate that angle. If you get a positive angle, it means that from the 0 degrees, you have moved anti-clockwise. And if you get a negative angle, it means you have moved from 0 degrees clockwise. And then if you were looking for angle of inclination, but then you got a negative angle, what you do, you just go and subtract that angle. Now it becomes your angle of reference. You subtract it from 180 degrees. Then it is going to give you the angle of inclination. So that is the relationship between the two angles. Don't be scared when you get a negative angle while you expect. That negative is not telling you how small the angle is. It is actually just telling you about the direction. So those angles, they are what we call the vector quantities in physics, because they have the magnitude and direction. Okay, I am not going to calculate that angle because of time. I want us to look at one of the concepts that we talked about, being an unknown angle. We are having point R, not unknown angle, sorry, the unknown point. We're having R, which we don't know its coordinates. But then we have an information which was given, and then there is a link. Because we are having line PR, we are having QR. Those are two lines which are defined by equation y is equals to negative x plus 2. Another line which is QR is defined by x plus 3y plus 6 is equals to 0. So to find the coordinates of R is the point of intersection of those two lines. And then in algebra or graphs and functions, when you talk of point of intersection, you know that your two equations are equal at that point. So you're going to eliminate one of the variables and then solve one, and then you substitute back to get the corresponding coordinate. So we are going to look, we are having y is equals to negative x plus 2, and then the other one is x plus 3y plus 6. So we can substitute y on QR to solve for the value of x. So I am going to have x plus 3. Instead of y, I am going to write negative x plus 2. And then plus 6 is equals to 0. Now I have eliminated y from my equation. I have only one unknown variable which now I can solve. So we remove the brackets. I'm going to multiply 3 in here. So when I multiply the 3 in, I have x minus 3x plus 6. And then plus 6 is equals to 0. And then you group your like terms. I have x minus 3x is negative 2x. And then I have 6 plus 6, which is going to be positive 12, is equals to 0. And then I solve for the value of x by taking 12 to the other side by its additive inverse, or I can take negative 2x. So I will have 2x is equals to 12. And then we remove 2, which is multiplying x by its multiplicative inverse. So x is equals to 6, because 12 divided by 2 is positive 6. So our x value at point R is 6. Then to get the corresponding y value, I can go to either line QR's equation and substitute the value of x to get the corresponding y value. Or I can go to line PR and substitute the x value to get the corresponding y value. That is going to be y is equals to negative 6 plus 2. And then negative 6 plus 2 is negative 4. So the coordinates of point R comes to positive 6, negative 4. And then again, like I say, whenever you are solving, make sure that your solutions are making sense to you. So our point R is in the fourth quadrant. And in the fourth quadrant, we know that x is positive and y is negative. So even if we made a mistake while we were calculating, at least our solutions are making sense for us to be confident about those. Okay. All right. The last thing that I just want to talk about, I am not going to do this question, but I want you to do it there. We are having on our sketch a triangle. And then if I tell you that I have another point, call it point S. Point S is somewhere in my Cartesian plane. But then S is in such a way that PQRS is a parallelogram. PQRS S is a parallelogram. And then my question says, find the coordinates of S. Now, when you find the coordinate of S, remember when I started about the pre-knowledge that you need, I mentioned that you need a very good background of grade 9 geometry. So it means for you to move from where we are to a parallelogram, you would need to know the properties of a parallelogram. So go and think about it, and then from one of the properties, you are going to find the coordinates of point S. Thank you.